Banta ma'am.
Sir.
Yes, ma'am. Please.
Start करें?
Yes, yes, yes.
Okay, sir. Once again, a very good morning to all of you. I welcome the session experts, the participants, the coordinators to the first session of the FDP on Foundation of Artificial Intelligence. We are honored to have with us Dr. Ranjan Patra as the session expert today. Dr. Patra holds a PhD degree in computer science from the Central University of Hyderabad and is a professor in the Department of Computer Science, Berhampur University. Currently, he is the head of the Computer Science Department and also the director of the University Computer Center. He has been teaching computer science since 1987 and has guided several doctoral students. He has about 150 publications to his credit. He has been a member of the Academic Council and Board of Studies of different universities and institutions. He has worked in the International Institute for Software Technology, Macau, China, as a United Nations Fellow, where he pursued research in some thrust areas in software engineering. During 2005 to 2006, he was with the Institute for Development and Research in Banking Technology, Reserve Bank of India, Hyderabad, as an assistant professor. He has extensively traveled to many countries, including USA, Australia, Europe, Hong Kong, China, Egypt, Bangkok, Macau, etc., for presenting research paper in international conference and chair many technical sessions. He was the program chair for ICDCIT 2015. He had served as a reviewer for different journals and as members of technical committee in many conferences. He is a member of professional bodies like ACM and life member of Computer Society of India, ISTE and OITS. Ladies and gentlemen, please welcome Dr. Ranjan Patra for the session. Sir, please.
So, should I start? Hello? Hello?
Yes, sir, you're audible.
Am I audible? Okay, yeah.
Yes,
sir. Namaskar, welcome, sir.
Namaskar. So, a very good morning to all of you. I just joined the last part of the inaugural function. I think it was very encouraging for the faculty members, kind of a motivation to start with this particular FTP. So before I begin, let me just ask you that same international question. Am I audible? Am I audible to all of you?
Yes, sir. Yes, sir. Audible, sir.
Okay. Yeah. So first of all, I'm very much thankful to GIT University for giving me this wonderful opportunity to be the first speaker for this FTP program. I'm sure that I can see there are about 119 participants for this particular program. I wish the great success for this particular event. I'm sure the participants as well as the speakers on different days will enjoy this particular program, interacting with the participants. And I believe when you go home after the end of this particular program, of course you are at home, meaning that when you conclude this particular FDP, so you'll have kind of a satisfaction, some kind of value addition to your knowledge. Let me start right away. Let me share my screen. So whether the PPT is visible now? Can somebody confirm it's visible?
Manu sir, just if possible, click on the hide button. Manu sir. Yeah.
Okay. Yeah, that's fine.
Thank you, sir.
Visible, sir. Okay. Okay. Right. So, as I understand this particular FDP under the AICT Atal program, specifically on artificial intelligence, machine learning, and deep learning, which will continue for the coming 5 days. I was just going through the schedule, the complete schedule to the end of this particular FDP to see. There are varieties of topics which are covered in all these days. I think most of these topics are very much relevant to this particular FDP. And this is basically a kind of a very focused FDP. It's not kind of heterogeneous, but it's very focused on artificial intelligence. I think it's rightly so. The organizers have chosen this particular topic because it's not only the scientists, not only the computer scientists, the academicians, and the industry people are talking about artificial intelligence. Even the politicians that have started using this word AI and machine learning in the parliament. The other day, I was just listening to one of the parliament sessions where one of the speakers said that we were using AI to track take the tax invaders, the IT tax invaders. So it was very amusing to hear a politician using the word artificial intelligence. So this makes us think that I think there is something nice, something very promising, which is there in this particular buzzword. This has become a buzzword, artificial intelligence and machine learning, almost being used quite synonymously. So that's why rightly the organizers have chosen this particular topic. All right. Now the first session is on foundation of artificial intelligence as it is reflected in your complete schedule. And of course, this being the first session, so no mathematics, no complex algorithms to understand. Things will go in a very smooth and story-like manner, and so that this gives you a good starting. Because I know the rest of the sessions from tomorrow onwards, from the topic I could see, you will be going through a lot of algorithms, a lot of mathematics, and maybe some hands-on using certain tools. As I was wondering, why is it really necessary to talk on foundation of artificial intelligence? Then as I prepared for this particular FDP, I realized, yes, sometimes it is always nice to go back and check what was the origin of artificial intelligence, how things are moving, what is the state of the art, and what are the promises of artificial intelligence. And that's what we're going to do in another 1 hour or so. So you can always stop me if you have some new ideas to tell or anything interesting that you want to share. And I'm sure that many of you are already teaching artificial intelligence either in the BTech level or in the MTech level, or if you're teaching the MCA students. It's very exciting. In fact, long back, some 30 years plus back, when I started my research in artificial intelligence, even I was wondering whether I'm going to really build a system which will exhibit intelligent behavior, which will replace human mind. So these were the questions which were there in my mind. And in fact, when I was doing my PhD in University of Hyderabad, we had a couple of very good people, the scientists from abroad, from the US and other places, from London and all, those who were doing very pioneering work. They visited and gave talk. So I had the opportunity to listen to them directly. And I had, over the lunchtime, I had some opportunity to interact with them just to know what is the trend of artificial intelligence, how it's going, and what are the promises it holds, at least in the field of computer science and, of course, in other fields. All right. So next 1 hour or so, we will spend the time to go back to the foundations of artificial intelligence and try to understand what is the state of the art and how things are. So I'm sure, I think I cannot miss this particular slide, because we have to remember, like the father of nation, so we have the father of artificial intelligence. I'm sure many of you know John McCarthy, who said, the science and engineering of making intelligent machines, especially intelligent computer programs. That is how he tried to explain artificial intelligence. He said it's a science and engineering, because science will give you a systematic study, and engineering will tell you to build a system, to design a system, to develop a system, to test it. For what? For making intelligent machines, and especially he was meaning intelligent computer programs. In fact, I just came across this particular writing, uh, which was given by McCarthy, Minsky, Rochester, Shannon, those who really started. They had a lot of contribution in it, not only artificial intelligence, but in computer science in general. So they wrote something like this. They said, we propose that a 2-month, 10 of artificial intelligence be carried out during the summer in 1956, College in Hanover, in New Hampshire, USA. Conjecture that every aspect of learning, of McCarthy, when you can see it's marked white, where he used the word artificial intelligence. I'm not saying that the word artificial intelligence was not there or people were not working in this direction. They were they were working in this direction, but they never use this particular word, this particular phrase, artificial intelligence. And that's how even you can see the date, August 31st, 1955. So they were planning for a serious work in this particular area. So I was amused to see this particular quote, intelligence and in computer science. That's where the word artificial intelligence was born. Now, somebody would really wonder, what is this? Why this word artificial? If intelligence, we understand what is intelligence, though you cannot really define it precisely quite for a long time. But again, why this prefix artificial? So obviously this will make us to think that it is artificial because it is not God-given, is not natural, but something that is being injected artificially, maybe by human being or in some other means. Probably that's the reason why the word artificial being prefixed before intelligence. Now, artificial intelligence is on the capability of a machine to produce rational, and we know how to respond to the external stimuli, right? So this is all about building or focusing on building machines with this capability of rational behavior. And the goal of artificial intelligence is to create systems that can perform tasks that would otherwise require human intelligence. So it's referring to certain tasks which are not mundane tasks, but I mean, things can be done, cannot be done in a stereotypical manner, but you require human intelligence to solve these problems, to perform certain tasks. And all these ideas are based on a very simple belief that the human brain is made out of biological computer. So they're trying to bring a similarity between the human brain and the machine, the computer. So they just prefer to call the brain, the human brain, as the biological computer, and that the mind is computational. Well, again, the philosophers, they will come up with a lot of questions trying to understand whether the mind is really computational. So all that you do in the mind, can that be expressed in the form of a computational formula, or at least they can be expressed as an algorithm? Okay, these are all $100 questions, $1,000, and people have been trying to answer this, whether the mind, the human mind, is really computational. All that you do, whether there's some kind of computation that goes on in a second, and you try to respond to external stimuli or not. So as you proceed, maybe try to clarify some of these the doubts and see what people have talked about this. Now, once again, people have been trying to define this word artificial intelligence. Now, there are three schools of thought, or there are three ways of approaching the definition of artificial intelligence. One is from the point of view of thinking, point of view of a thinking machine, that you are trying to build a thinking machine or machine intelligence. The other approach could be trying to understand the cognitive behavior, the cognitive faculty of human being, the thought process that goes on in the human mind. And the third one is little realistic, little practical. It's all about solving problems intelligently, writing intelligent programs which can just solve the problem without getting into the building of a machine, thinking machine, or trying to understand what really happens in the human mind. Now, people, those who are following these three different schools of thought, they have their own ways of defining this word artificial intelligence. The first one, those who think that it's a thinking machine, or it's all about machine intelligence, they try to define like this: the study of how to make program or computers do things that people do better. And the second definition given by somebody else is the study of how to make computers solve problems which require knowledge and intelligence. And it goes on: the exciting new effort to make computers think, machines with minds. And the fourth one, the automation of activities that we associate with human thinking, that is the decision-making ability and the learning ability. The people, those who struggle to understand the cognitive behavior in the human mind, they have a slight different way of expressing what artificial intelligence is. They say, it's the art of creating machines that perform functions that require intelligence when performed by people. The second definition goes like this: the study of mental faculties through the use of computational models. I think trying to understand the mental faculties through computational models probably gave rise to the concept of artificial neural networks and all the derivatives of that we see in the form of feed-forward networks or RNN or CNN, things like that. And finally, the definition goes like this: a field of study that seeks to explain and emulate intelligent behavior in terms of computational process. So people, those who try to understand the thought process, the cognitive behavior, they tend to give definitions like this. And the last one, which almost all of us, they agree, and we have been trying to do, at least at this point of time, it's a branch of computer science that is concerned with the automation of intelligent behavior. So if you can express that how a particular problem solving is carried out, whether you can automate that, and we will be very happy to call that as an intelligent machine, because it's trying to do things the way I would have done, the way you would have done, or an expert would have done it. So it's much more realistic, and that is what we have been doing. That has been the
Sir, please unmute yourself.
common question. Oh, Acha, all this time it was mute?
No, sir.
Hello?
Now it's okay, sir.
Okay, sorry.
Yes.
Okay, sorry. So, people have been trying to understand the construct, the constituent of the human mind, and probably they thought it consists of a huge number of biological neurons, and they try to mimic that by forming a huge number of artificial neurons, computational units, the processing elements, as we call them, PEs, processing elements, and the complex interconnection that gives the ability to capture external stimuli, store them in the form of knowledge, in the form of in terms of weights, and the adjustment of weights would mean that the neural network is learning, and then probably you try to present it in neural situations. So it try to behave, try to predict, try to classify, things like that. right? So that is how the work was already going on. And then people said, okay, I have made a machine, I have built a model which is able to predict things, which is able to classify things. And then Turing came up and said, okay, if you are saying that your machine is trying to behave intelligently, or your model is trying to behave intelligently, let me test it. So he came up with this Turing test. We'll see that. And then I think it all went on, in 1956, the birth of the word AI, and the first system came out like ELIZA, and so on and so forth. There are a lot of things that happened, so I'm not going to go through each one of them. And in all these years, people have been trying to build intelligent systems, either in the form of software or from a robot, either to play games or to do a specific type of job or to build a recommender system, so that people are happy, but because the machine is able to analyze huge amount of data and give the right kind of recommendation to proceed further, or the machine is enabling somebody to take the right kind of decision, and so on and so forth. So that's what things went on quite for a long time. Now, if you think that artificial intelligence is a separate area altogether, it's not true, because there are a lot of other branches which are actually contributing to the research in artificial intelligence. I still remember my guide to ask me to read books on sociology and books on philosophy to understand what really happens in the human mind when it gets some external stimuli, right? So one could really appreciate the input from branches, from multiple branches like sociology, from mathematics, from philosophy, from biology, from neuroscience to psychology, even computer science, mathematics, and so on and so forth, which contribute in some way or other, either conceptually or helping to build a real physical artifact where I can see some intelligent things happening. So all these branches have been contributing to the research area in artificial intelligence. And the things which people are trying to achieve, the functions that people are trying to achieve, is how the human mind does reasoning, how reasoning takes place in the human mind, how the human mind actually learns, how the human mind actually solves problems. So those are the intriguing questions which all the time bother people working in the area of artificial intelligence. And people try to find solutions from all these areas, right from sociology to philosophy to biology to mathematics, to have a clear understanding of the reasoning capability, the learning capability, and the problem-solving capability of human minds, so that those things can be translated into intelligent programs or intelligent machines, so that the real, the benefit of AI can be really felt. Now, there are many subfields, though we use the umbrella term artificial intelligence for all these things, but there are some subfields which are very prominent, and people have been working in these specific areas. Okay, I'm not saying this is fixed, this is limited, but it's quite exhaustive. But some of the most common sub areas of artificial intelligence are building expert systems for fault finding, for diagnosis of diseases, for building recommender systems, things like that. And people also have been working in the area of natural language processing, NLP, where they try to generate, where they not only try to understand natural language, they try to build natural language interfaces, they try to synthesize text from the speech, generation of artificial language, and things like that. Speech recognition, all the time that has been a very active area of research. The machine vision, understanding visual images, understanding patterns. Robotics, of course, it has a lot of industrial applications, because wherever the human beings cannot reach, maybe there's some poisonous gas, or maybe some places where it's quite dangerous for the human being to enter. So probably the robots are being deployed to do that. Not only to do industrial things, but robots are also there to play games. You might have seen in the television. So we have robots playing chess, robots playing hockey, robots playing football, and things like that. And the last two areas have become very popular in the last decade, at least in the last part of this particular decade, and people have started talking about machine learning. It appeared for some time that people forgot the word AI, and they have started using this word machine learning quite synonymous with AI. Because I remember when I was writing papers and sending to different conferences, there were some critics where they're saying just the word artificial intelligence is just a hype, and it will have its natural death over a period of time, and people will forget about it because there is nothing like artificial intelligence. It's just a hype. So I'm not sure. I'm not going to respond to that. But at least after 20 years, I can see the same thing has come with a new term, machine learning, meaning the same thing, because artificial intelligence also talks about machine learning. Of course, it didn't use the word machine learning, but learning was very much there, because it was there right from 1943 when people came up with the concepts of neural network. So it has come with a new name like machine learning, and people have really gone forward, move ahead with adding another new term like deep learning. So I can see there are a lot of lectures in these areas. You will be enjoying very interesting algorithms on machine learning, deep learning, things like that. To read all of them, because you can see that it really starts from finance to data security to agriculture to education to automotive to healthcare, astronomy, gaming, and everywhere. So wherever you think that human beings would have done it much better, because it depends on the reasoning capability, the learning capability, or decision-making capability of a human being. In all those applications, one can bring in concepts of artificial intelligence, intelligent algorithms, and AI problem-solving techniques to handle such issues. That's how the applications of AI is all pervading, and you will find the AI everywhere. And that's the reason why AI even has entered into the parliament, and people start using this word AI. Now, for some time, let's really go back to the philosophy, the very objective of artificial intelligence. Somebody switched on, I think. Will you please switch off or mute your mic? Yeah, thank you. The philosophy of artificial intelligence. Now, what's the philosophy of artificial intelligence? While exploiting the power of computers, because computers were already there, and when people started using computers, and obviously they had that curiosity in their mind, because human beings are always very curious to explore new things. Now, this curiosity in the human mind led to think that can a machine think and behave like human beings? Maybe initially when they used computers to solve simple problems, which was taking long time by human beings, they thought maybe the computer is quite powerful to think like human beings and behave like the human beings do. So that is how it all started. So the development of AI started with the very intention of creating a similar intelligence in machines that normally we find in human beings. So that was the starting point probably. It is the inquisitiveness in the minds of human beings to see, to build, to realize a machine which can think or behave like a human being. Now, so keeping this in mind, people have been trying to implement human intelligence in machines. Now, what are the attributes of these machines which they are envisaging? They are envisaging that these machines can understand. These machines have the capability to think, to learn, and to behave like human beings. So that has been the objective of artificial intelligence. And if you cannot achieve all those, but at least a subset of that, which has become very popular, like creating expert systems to solve very domain-specific problems like diagnosis, fault finding, decision making, forecasting, things like that, where there also you can see their intelligent behavior, because in all these expert jobs, you require an expert. For example, you have a cardiologist who has expertise in understanding the problems with our heart, and he can diagnose the disease and he can recommend the treatment for that. It can demonstrate the intelligent behavior. It can learn. It just not only perform certain things, but it can also explain why it is done in a particular manner. And probably it can also advise, it can recommend, it can suggest, it can prescribe remedies for certain problems. So these are the driving force or rather the goals of artificial intelligence. Keeping this in mind, people have been working in the area of artificial intelligence. Now again, even after you try to define what is artificial intelligence, but people will still ask you the basic question: what is intelligence? So is there any common consensus as to the definition of artificial intelligence. Is there a holistic definition for intelligence? Now, people have been trying to define this. Some would say it's the ability to comprehend, means to understand and profit from experience. Somebody would define it, it's a general mental capability that involves the ability to reason, do reasoning, to plan, to solve problems, think abstractly, comprehend ideas, and use languages, learn over a period of time. And some would define it saying that it's effectively perceive the stimulus coming from the environment. It can interpret those stimuli, and it can respond to the environment. So people have been defining it in different ways. So obviously, there's no commonly agreed upon definition for that, and because none of these definitions would tell us what intelligence is, but we can see the effect of an intelligent person if we can see the behavior of an intelligent human being, the way he or she does a particular job. A human being probably can perceive the stimulus around that. It can store those things using the appropriate mechanism in the human mind. It can reason with that. It can infer things which are not told to the human being, but can infer, it can deduce through a logical deduction process. It can solve problems with the expertise that it has gained over a period of time. It can learn over a period, the human being can learn and even unlearn certain things over a period of time and trying to fine-tune its learning so that it can behave very specifically as correctly as possible in a given situation. As time progresses, it can adapt to situations. It can apply common sense that it has gained, that he or she has gained over a period of time. It can try to bring similarity, analogies. It can recall certain things, certain events, certain facts, certain happenings that had happened in the past. It can apply intuition, the human mind, very intuitive, and it can also reach emotional states and achieve self-awareness. So these are the common things that normally you see in an intelligent human being. Now, if you are trying to build an intelligent machine or intelligent system which will exhibit all these features, probably will be tempted to remove this word artificial and you just use the word intelligent machine. But as you can see, I mean, as the word says, it's not that simple to implement all these things because they are very complex things which happen so automatically in the human brain that it's very difficult to really understand what's happening in the human brain. So what is the difference? By now probably you'll be able to understand what is the difference between being intelligent and demonstrating intelligent behavior. Again, this is a philosophical question. What is the difference between being intelligent and demonstrating intelligent behavior? Being intelligent is the property, is the behavior of a human being. But demonstrating intelligent behavior, probably, that's the kind of a capability it can be injected, it can be given to a computer system, either through a software or a software hardwired into a chip and ported onto a robot or a hardware device. So that's a thin difference between being intelligent and demonstrating intelligent behavior. We are not trying to do the first one. We are not trying to build a system which will be intelligent, but we are trying to build a system which will demonstrate intelligent behavior, and that too only a subset of the intelligent behavior as it stands today. Of course, as time progresses, probably we'll be able to achieve more of the intelligent behavior in a machine or a system. Now, I think all of you know about this Turing test. Through this Turing test, Alan Turing, way back in 1950, so basically it was a imitation game. So you're trying to imitate something. And he said, okay, any system that passes this Turing test probably can define this word intelligence, intelligent, right? So it was a test designed to test whether a system is intelligent or not. Now, this figure shows that, well, so a wall separated a computer and a human being. On one side of the wall, there's a human being. On the other side of the wall, there's a machine. And again, it's separated from the human being with another wall. So the human tester is not able to see the human being and the machine on the other side, which are there, and it's not visible to the human being. And the human being is asking questions. And sometimes the computer is responding, and sometimes the human being is responding. So the one who is claiming that, okay, I have come up with a computer system which can respond intelligently, so the program is intelligent, program is running in that particular machine, whereas on the other side, the human being is trying to understand the questions posed by the human tester, which he's not able to see, and trying to answer the question. And the story goes on for some time on any topic, depending on what domain the questions have been designed and the machine has been designed to answer. Over a period of time, if the human tester cannot distinguish between the human being and the machine, then probably it can attribute intelligence to the machine, saying that, okay, now I'm not able to understand, I'm not able to distinguish who is the human being and who is the machine, because both of them responding exactly in the same way, and that's the reason why I'm not able to distinguish. And then probably the one who has designed the machine can claim, yes, I have built an intelligent system. I have built a system which exhibits intelligent behavior. So that was the test which was designed by Alan Turing. Now then, okay, the test, of course, though he designed the test, but people then argued that whether a machine which passes this Turing test can really be called an intelligent machine. Well, again, that triggered a variety of questions. Again, people went back to understand what is intelligent and exhibiting intelligent behavior and being intelligent, again to the same basic question. Now, based on this Turing test, there was a system which was designed, ELIZA, and I think many of you know. Again, this is basically a dialogue that took place between the doctor, the ELIZA was the doctor, and who was asking questions to, and the human being was responding from one side, and again, the machine was designed to answer the questions. And the ELIZA was designed in such a way that it would pick up, the Dr. ELIZA would pick up questions, the ELIZA will pick up the keywords from the question, and it will try to ask another question. So it's not the human doctor who is asking, but ELIZA is asking question to the patient, and by taking the keywords from the responses of the patient, and he asks another question, and the dialogue goes on, and probably the ELIZA is pretending as if it's trying to understand or it has understood the patient. That was all designed by Joseph, and now we have a better version of that called Alice, which probably you can see in this particular website. They have made a lot of improvisation on the design of the ELIZA, and Alice is much more realistic than ELIZA, because ELIZA failed at some questions which to which it could not respond. And this is how the dialogue would go on. Probably the human being will ask men and will make a comment saying that men are all alike, and ELIZA, E means ELIZA would ask in what way. Then the human being would say they are always bugging us about something or other, and the ELIZA would respond, can you be more specific? Then the human being would say, well, my boyfriend made me come here. ELIZA would ask, your boyfriend made you come here, and so on. So you can see how the ELIZA is picking up certain keywords from that has been used by the human being and posing the next question. Right? That's the way the test was done. Now, similarly, the Alice was another one which was also demonstrated. Again, a set of things. Somebody called Jerry is asking, saying that, okay, my name is Jerry, and Alice is responding saying, hey, Jerry. And Jerry says, do you know Turing? And Alice says, okay, a brilliant and a tragic figure in the history of computer science. Something is going on, something like that. Now, so here, when the dialogue goes on for a long time, when certain questions were asked at a later stage, still Jerry is able to remember certain things which were asked long back. So it has a memory, where ELIZA was not equipped with a memory. So it would work in a very short-term memory and respond to questions, whereas Alice has a memory and it could always refer to something happened in the past, and it could behave as if it's remembering a lot of things, trying to retrieve from its memory and responding to the question posed by the human. So that is how they could achieve. But then at some point of time, somebody came out with another interesting experiment where they're trying to contrast between Alice and ELIZA, and the questions were posed to ELIZA, and they were talking. Alice and ELIZA both were talking to each other. Both were computer programs were talking to each other. So, for example, it all started ELIZA saying, "I am ELIZA," and Alice said, "I am very pleased to meet you, ELIZA." And then ELIZA would say, "How can I help you?" Alice said, "Just keep talking to me. as long as you can. And then Eliza would say, do you wish as long as me? Then Alice says, okay, I will as long as you. Then Eliza says, do you wish to will as long as me? Then Alice would say again, okay, I will as long as you. So from here on, I think they're missing the track, right? So they're not able to really understand certain things, and this I will is being used as a noun, and the subsequent sentences are formed like that. So which means this says that both got stuck when they came across this word I will again and again. And that makes us understand, I mean, it clarifies that neither Eliza nor Alice actually understood what they were talking with each other. They were only using certain text. The text were just symbols to them, and they were just picking up certain phrases, and they were framing the next sentence. So however smart Alice could be when it was designed, but it also failed because there was kind of a recursion, and it never came to a stop. And it was slowly realized that they got stuck in this word I will, and they were not able to move forward. See, the idea of saying all that is just to tell that this was kind of a symbol processing that both these Alice and Eliza were doing without really understanding, right? So one of the attributes of human intelligence is to perceive, to interpret, means to understand, which was not there in the behavior of the first these two programs, Alice and Eliza, which was designed to interact with the human being or even to interact with each other and exhibit human-like behavior. So here it makes us think or to contrast between two things. One is the table lookup, the other one is the real reasoning. So what these Alice and Eliza were doing is kind of a table lookup, because something was already stored, they were designed, there were some rules that they were following, and they were trying to respond to the questions which were posed by each other. And there was no reasoning that was happening, right? There was no reasoning as such. And that's the reason why they got stuck when the word I will was used, and it was recursively used by both of them. So the first solution, if somebody is trying to use a table lookup, where there are some standard set of pre-enumerated text or pre-enumerated moves, if you are trying to use the table lookup kind of an approach to solve the tic-tac, the famous tic-tac-toe problem, so probably one will list a set of pre-enumerated best moves given certain board configurations, and the system would pick up one of the best move at any given point in time. But in the second solution, probably you use certain heuristics, you will use certain rule of thumb, and every time the system is supposed to evaluate the board configuration and all possible movements and then find the best, right? So the second one, the reasoning would demand that, would require this kind of an ability in an intelligent system. Now, obviously, we just saw that Eliza was using the first one, the table lookup, and there was no reasoning that was happening in the minds of course, there was no mind in the program itself. There was no reasoning happening, and it's very difficult to build this kind of a lookup kind of an approach to solve problems like tic-tac-toe or let's say chess or other complex games where there are two players and there are a lot of interactions that going on, and obviously they will fail the Turing test. So our approach is always to build a system which can reason. Then probably we can think that yes, it is also thinking, or it is trying to, at least trying to mimic the thinking ability of a human brain. So where probably the machine is supposed to analyze a given position, a given configuration, and make a move. Is not just make a move, but still be able to explain why it make a move in that particular situation. And somebody else also designed another problem to test, to tell whether a system is really intelligent or not. That was known as the famous Chinese room problem, which almost goes in the same way. It was designed by another philosopher called Searle, John Searle. So he said, okay, suppose you keep a person who doesn't understand Chinese in a particular room, and let's say we have a mechanism through which you can speak out certain Chinese, you can make questions in Chinese, and suppose this person is equipped with a storage where there are some Chinese words which are written there, which are available, which can be accessed by this human being. So there is a book of Chinese symbols. Now, when the question is posed, this person again looks at certain patterns and refers to the stories, refers to the Chinese book that he's carrying with him, and frames the answer, and the answer goes out of the room, right? So now, probably for certain simple question, this person, because he's doing kind of a pattern matching without really understanding what is reading and what is writing, will be able to answer satisfactorily. But over a period of time, when complex questions are asked, again, this person could not, because that requires some kind of reasoning, right? So that was a test designed by Searle called the Chinese room problem, where questions were asked in Chinese to a person who does not understand Chinese, but still it could answer to certain questions because he had access to some Chinese book containing certain Chinese words, certain symbols, some patterns, which he used for simple questions, but later on it failed. So that showed that it was not really understanding, the reasoning was not available to this particular person. Now, in the same way, probably if you can replace the human being by a CPU and the memory by and the storage by the memory and your data or the program or a huge ontology where you have set of Chinese words, and if you can build a machine to do in the same way, probably the computer will be able to answer simple questions to start with. But over a period of time, when complex questions are asked and when reasoning is required, then the system will fail. So that was again a test like Turing test to test the intelligence of a computer system. So what was the conclusion of Searle? He said, did you understand the Chinese messages being communicated? Obviously no, because the machine was using some kind of symbol matching. It was doing some symbol processing. So he concluded that computer is not intelligent. It has no semantics because it doesn't really understand the meaning, but instead is merely a symbol manipulating device. I think that was a very nice conclusion drawn by Searle. He said it is not, a computer can never be an intelligent machine because it doesn't operate on semantics. Instead, it operates on symbol processing because of the symbol processing, symbol manipulating capability of the device. The computer operates solely on syntax and it not on semantics, right? So that's a philosophical manifestation of the Searle's understanding of intelligence, and that gave rise to two words like what is known as strong AI and what is known as weak AI. So strong AI is always in the pursuit of machine intelligence, which means making a machine intelligent to act like human being, the way the human beings actually perform. But this is quite ambitious. And what is the other aspect? The weak AI, which is in the pursuit of machines solving problems in an intelligent way. I think this is what we are aiming at. We are trying to build machines. We are trying to build systems which will behave or which will solve problems in an intelligent way, right? We are not trying to make machines which will think like human beings. Right? That's what we try to distinguish between these two, the strong AI and the weak AI. So then it makes us think, where is the intelligence coming from? Now, again, there are three different approaches to that. One is the systems response, where the hardware by itself is not intelligent, but it's a combination of the hardware, software, and the storage, which is intelligent. There is another approach which says talks about robot response, where a computer is void of senses. Like for example, a robot cannot sense, cannot smell, cannot feel anything. But therefore, the symbols are meaningless for these kind of artifacts. But a robot with sensors probably can do that, because when the sensors technology came, the robots can be fitted with sensors and they can sense certain things depending on the capability of a particular sensor. Probably some sensing can be done. And the third approach is basically it talks about the brain simulator response. If we program a computer to mimic the brain, for example, let's say the neural network, that's what we have been doing to train a neural network, then the computer will have the same ability to understand as a human brain. So this is what people have been trying to understand, where from the intelligence really come. Now, are you really trying to compare the human brain with a computer? Because if you're trying to do that, you're trying to assume that brain is a form of a computer. I'm not sure whether this is the right assumption or not, but that's what we're trying to do. We're trying to bring a similarity between the brain and a computer. And whatever that you have in our mind, but our objective is to create a computer intelligent. Tell to the computer, because a program which gives intelligence to a hardware system, just like the people, they behave in an intelligent manner, the way they learn, they respond to different situations. So the computer performs tasks without really understanding. That's what Serle said, because it does based on symbol manipulation. It operates on syntax rather than semantics. Now, sometimes even for human beings, maybe we will be tempted to ask, does the brain understand what it's doing when it solves problem? Now, this is the funny question probably you can ask to our students. So whenever we do something, whether the human brain, even the human brain, whether it really understands what's doing, because many of times the students, they try to remember certain things without really understanding before the exam. And when they see the question, and when they see certain keywords in the question, they start writing whatever they try to write, whatever they have remembered just the last night, without really understanding. Right? So I always remember the story by my teacher. So the student went prepared with an essay of cow. Now, when the question was write an essay on flood, so he gave all the description and finally said, and somewhere in the beginning he said, okay, I saw a cow floating in the river because of the flood, and he started explaining what is a cow. So that's how he shifted, because he didn't really understand what was asked, right? So even when the human beings they act in an intelligent way, many times we are not very sure they really understood what was asked, or they just did some things accidentally or whimsically or as a quick response intuitively. Okay, so again, we are not going to those tricky things in the human mind, because various other states which really define whether the human being really understands or it's also doing kind of a symbol processing. So people try to contrast between these two manifestation of artificial intelligence, whether it's weak or strong. Whereas the weak intelligence embody a system designed to carry out one particular job, one specific job. Like for example, we can design a video game to play chess, to play tic-tac-toe, or a particular type of a game, or a kind of personal assistant that we build, maybe a email assistant, which looks over our shoulder and tries to learn the way we respond to the mailbox. The emails that you see, the emails that you skip, the emails that you try to see on the top of our mailbox every day, or the emails that you just leave unattended, kind of a personal assistant. Like these days we see the Amazon's Alexa or the Apple's Siri. So these are basically implementing the concept of weak artificial intelligence, because they are designed for a particular job. Whereas on the other extreme, we have the strong artificial intelligence, which refers to systems that carry out multiple tasks that would require human-like behavior. They are more complex, more complicated, which require intelligence, which require high level of reasoning capability, and therefore they are all programmed to handle with. And if you are really targeting the building of such a strong AI system, you like to have those capabilities with which these systems can handle certain tasks, certain problem-solving activities without human intervention. Because today, even if we have expert systems, most of these expert systems cannot do certain things completely unattended by a human being. At some point of time, human beings have to interfere and to interpret in the dialogue that is taking place between the expert and the computer expert, the software, and the human being which is interacting with that. So that's the reason why many times we call all of them as the support systems. They try to facilitate interactions, but probably at the end, when it comes to real decision making in a complex situation, you need the intervention of a human being. So somebody is really ambitious, can be called as ambitious if he's trying to build a strong AI as the technology stands now. Now, people have defined AI in from two different angles, two different points of view. One is based on the capability, and the other one is based on the functionality. So if the categorization is based on capability, now people talk about these three types. Just now we saw the narrow type, the general, and the strong AI. When people depend on functionality, just a minute, sorry. Just a minute. Online class. So capability, extremely sorry, there was a call, so I had to attend. So if it is functionality of AI, then probably we have 4 different categories like reactive, limited memory, theory of mind, and self-awareness. Now, in the first category, the weak and the good morning. Just a minute. Sorry for the interruption. Just back in 1 minute. Extremely sorry. Online website. I just completed it. Man, so I'm back. Am I audible now? Hello? 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 Hello?
Yes, sir.
I'm sorry. So the Vice Chancellor came to my room, so I had to pause for a while. So the weak or the narrow AI is a type of AI which is able to perform a dedicated task with intelligence. That's the system, the present system that you are looking at, that you are aiming at, and it cannot perform beyond its domain. So that's why I say it operates just one specific task, and hence it is also termed as weak AI. Right? It's very specific in its operation. It can fail in unpredictable situations. When the system is confronted with a unpredictable scenario, then it can fail. The computer programs, the recommender systems that you're talking about, even the self-driving cars, the speech recognition systems, the image recognition systems, they all come under a weak AI or the narrow AI. Now, the general AI is a type of intelligence which could perform any intellectual task that requires the efficiency level of a human being. Now, this is the idea behind the general AI, to make a system which can outsmart a human being because it can think like a human being does. Now, currently there is no such system exists because you have not come to that level of maturity where probably we'll be able to perform this kind of a very generic intelligent activity. It can perform any task as perfect as human being. So that's the ultimate aim, which is hard to achieve at this point of time. Now, here the research focus has been to develop machines with general AI. So because this will keep us moving to achieve the final target, and we don't know whether we'll be able to achieve that. But this will keep us moving forward, driving ahead, so that the AI research is always live. Now, there is another way, I said super AI. So this capability, this intelligent capability actually surpasses the human being, where the machine can outsmart a human being the way the human being would do, because it will have a higher level of cognitive properties. Now, what are those cognitive properties and how exactly those will be manifested? So that only the philosophers can talk about that. But certainly a higher level of thinking, higher level of reasoning, making judgments, planning things ahead of time, and even the AI systems communicating with each other. The one that we just talked about, Elisa and Eliza, they're talking to each other. So where the systems can interoperate, they talk to each other, and they can take decisions, right? Now, This is basically a hypothetical concept of AI at this point of time as it stands now. Uh, Okay. Now the other one which categorize AI based on the functionality, it's all about starting from the limited memory to reactive machines to theory of mind and self-aware artificial intelligence. We have the four different areas in which people have been working. The reactive machines, which is based on the principle of how it responds to the external stimuli. Now, if it is a limited memory kind of thing, where the intelligent machine has a limited memory capability, and it can refer to certain things of the past, and based on experience, it can do certain things. If it can go a little forward, the theory of mind, basically the system can really understand the way the human beings do. It has the capability of emotions, the people believe, and the ability to interact even as social beings. Now, to some extent, probably here I can talk about a model called the BDI model, belief, desire, and model, which is based on the theory of mind, where we are trying to mimic the intelligent behavior in terms of the belief system of a human being and the things it desires to do and the intentions at a particular instant of time where the human being converts the long-standing goals into the goals to be achieved, right? So that's the way they try to implement. That's the way they try to implement the theory of mind in the form of the BDI model. Now there is another one called the self-awareness model. The self-awareness AI is the future of artificial intelligence, and these machines will be super intelligent and will have their own consciousness, sentiments, and self-awareness. Now, when I talk about consciousness, sentiments, and self-awareness, now at this point of time, we're not very sure that how these ingredients can be made available in a machine: consciousness, sentiments, and self-awareness. And obviously, if we can really come out with these kind of intelligent machines, they will be smarter than the human mind, the way they act under different situations. So again, this is hypothetical and it doesn't exist at this point of time. So what does just a minute. Hello. ଏବେ जस्ट केउट आनी दला टेबल पर रखला मु देखिनी मु टिके मु परे करिए से चलची गोटे ऑनलाइन चलची मु टिके कंप्लीट कर दिया. Extremely sorry for this interruption. Okay, so what does AI do in that case, right? So you can talk a lot of the theory, but what does AI do? So if we want to have a feel of AI and trying to build something which is realistic, which can be which is implementable at this point of time, probably we'll be trying to do one of these. The first one could be select a specific problem that we think it requires human intelligence, select a specific problem to solve, study the problem, perhaps try to understand how the human beings would solve this similar problem, and then you come up with the proper representation of the knowledge that is necessary to solve that particular problem. Try to acquire that knowledge and try to codify that knowledge in a computer readable form. And all of us know there is there are so many knowledge representation techniques which are available, which is another branch of AI, where you try to represent knowledge in the best possible way, whether it's which can be a forward chaining rule based or a backward chaining rule based system. The semantic network, the semantic. Hello. Hello. you try to acquire that knowledge and codify that knowledge. Just please hold on. So and you try to acquire or codify the knowledge in a computer readable form, and then build a problem solving system. And there are many such representation schemes like semantic net or the rule based or a frame or a script. Now all these methods basically give you a capability to represent knowledge in a particular manner. It's not that the knowledge is represented, can be represented, but you must have a robust mechanism to reason and try to interpret things which are not available in the form of fact, right? So that's the way you are trying to build systems where you are trying to represent knowledge and also do reasoning. That can be the first approach if I'm trying to solve problem using the first approach. But the second one could be select a category of problem or a cognitive activity. Basically, you're trying to understand the human learning ability, the natural language understanding, and theorize a way to solve the given problem. Build systems based on model behind your theory as experiments, and modify that as needed. So one is basically targeted to solve a specific problem. The second one is trying to build a generic system because you have thought about a cognitive model which you are going to apply to the particular system. Just for instance, if I understand the human brain consists of biological neurons, and then I'm trying to mimic that in the form of a neural network. I'm trying to build that in the form of a neural network and trying to mimic the learning capability and the response behavior of a neural network. Now, both these approaches will require some kind of a knowledge representation. Just now I mentioned, whether in the form of the rule-based system or a semantic net or a frame or a script, or a learning system like a neural network. So if you represented your knowledge in the appropriate knowledge representation scheme, one of the core things that emerges is how quickly you can locate that knowledge in order to solve a particular problem. So this is where we talk about different search techniques. Those who have already taught AI, you might have come across a lot of search techniques. So searching forms the core of solving problems, problem solving through searching. So in what happens in the problem solving through searching is basically you are trying to design a state space which consists of all possible scenarios in a particular problem domain, and we are trying to find solutions by navigating in that state space, trying to read. Whether you talk about a tic-tac-toe problem as the state space looks like on your right, or whether you talk about the 8 puzzle problem or a chess playing or the water jug problem, all the problems that you see in the normal in our AI textbooks, we try to model the problems in the form of a state space where you try to capture all the possible states. States basically carry a particular configuration of certain parameters and that particular point in time, and we make use of those values in order to make the best move in that given situation. So essentially it's a state space search problem. So everything, the intelligent way of solving problem ultimately boils down to a state space search problem, where basically you're trying to reach the goal by following the optimal path. And that is what most of our AI approaches are doing today, and that is what we have been trying to do. Now, these are some typical search algorithms like the breadth first search, the depth first search, and different types of heuristics, the hill climbing, the A star, the best first, and of course, if it's kind of a game, then it's a minimax or alpha beta cutoff as you call it, or probably we can add certain constraints in our search part. We can use the genetic model of algorithms to optimize our search path, or it can be a forward or backward chaining method, which is essentially either it's a data driven or a goal driven approach. Now all these search algorithms will just enable us to find a solution in optimum time in the best possible manner in a given situation. And most of the AI research today revolves around this approach, at least at this point of time, that the AI problem being modeled as a state space search problem. Now, people have been working in different areas, and that's how the current research now focuses on building intelligent agents. So by saying intelligent agents, I'm referring to intelligent software agents, or a set of agents interacting among themselves in in a social network setup, which we call them as the multi-agent system, where we talk about collaboration, which we talk about interactions, which we talk about some kind of a cooperation among agents in order to solve problems in the real world. These days, I think people have started talking about blockchains. That is again a scenario which requires certain aspects to be handled, and you need a huge number of agents interacting among themselves to enhance the trustworthiness of the distributed transactions happening in different places. There are very interesting applications using intelligent agents. Now, there are search engines which are being built to locate the required information following an optimal path, filtering of information, and building recommender systems. And areas like natural language understanding, information retrieval, speech recognition, planning, diagnosis, and so much so interpreting the information gathered through a huge number of sensors which are deployed in different areas, because you don't want to overload the network. Therefore, you do interpretation at the root level, and you try to send the information which are relevant to in a given situation. The visual understanding, the robotics. So these are some of the interesting areas where probably people have been working in all these years, because they find that these are the applications which require human intervention, which require human understanding, reasoning to handle such problems, such issues. Now, what has been the approach to handle that? Most of these solutions are based on building robust knowledge-based systems, building ontologies, at least for speech understanding, at least for language processing. It heavily depends on the ontologies, based on which ontologies basically is a dictionary, is a huge repository of data, which will enable them to interpret the meaning of certain words being used during communication. The probabilistic networks, the Bayesian networks, and of course the data learning techniques which has come up, which has become so familiar today, the data mining techniques, the machine learning techniques, using all kinds of neural networks, the fuzzy logic, genetic algorithms, and so on and so forth. The mathematics has come in a very big way to provide solutions to scenarios where you need to interpret the fuzzy information and still make your inferences based on that. And that, of course, led to the topics like the deep neural network or deep learning, right? Basically, it's a branch of artificial. Okay, I will not go into the definitions of all that. So, as you can see in this diagram, artificial intelligence is an umbrella term, and machine learning, which is a subset of that, and neural network is one such approach, and probably it is further specialized in deep learning because it operates on huge amount of data and tries to understand a deeper meaning of data. It's not just matching patterns or trying to respond to certain scenarios based on pattern analysis and a limited level of learning, but a deep level of learning using different layers of the network. Now, if somebody is interested to know, I'm sure that there is a talk on that, so I will not go into the details of deep learning. But one can probably see that how one tries to understand the problem to start with, and it's not that you try to jump into deep learning for any kind of application, but there may be certain problems for which you require deep learning approaches to handle that. Because one of the weakness of human being is the researchers is, so anything that comes new, we are tempted to apply that in our application domain, whether it is really required of that or not. Because I understand deep learning would take long time because it's going to analyze a huge amount of data, right? You could have solved the same problem using a simpler approach, a simpler model, computational model, but unless you jump into those kind of scenarios. Therefore, understanding a particular problem and judging the level of intelligence that is required, the level of processing that is required to handle those issues is very important, and then simply using some technique. Because many times if you are given some data set, either you get it from the KDD Cup 99 data set, or the or any other data set available in the public domain. So people experiment by using different types of techniques without really understanding whether those techniques are appropriate for those kind of data sets, right? Unless you understand what are the features, which features really contribute to actually training the system in a better way, and how it can enhance the accuracy of your prediction, classification, whatever that you're trying to do. So without understanding that, many times we jump into the technique. So as a thumb rule, as a heuristic, one must really analyze the features and what you're trying to do. What is the size of the data set? How many features? The features which really contribute, right? So only when you have this kind of initial understanding of the problem domain and the data set on which you want to apply, then you need to carefully decide which algorithm will best suit to that, right? So this is just a difference between the machine learning and deep learning. Well, of course, I mean, these are all textbook things. Probably you can do that. As machine learning would work on a small amount of data, but the volume of data that is available to the deep learning algorithms are very huge, and that's how they need a very complex structure to understand that. That would take long time to train the system, but once it's trained, then probably it will be able to behave, very close to as a human being on those application domains for which it has been trained. That's how it goes on. And there are, of course, different approaches to do that. It can be a supervised learning method, which takes care of, which of course includes networks like FFN, the feed forward, or it can be the convolutional neural network, CNN, or it can be a recurrent network, the encoder decoder architecture, the unsupervised learning, the autoencoder, the genetic advisor networks, the reinforcement learning. I saw that all these topics are to be covered in the coming days, so I'm not going to that. But there is a small architectural difference and the manner in which you train and test your system, whether it is supervised, whether it is unsupervised, and the layers you want to have in the as the hidden layers, and what is the input signal, and what kind of operation, whether it's a prediction problem, or whether it's a classification problem, or whether it is an interpretation problem, or whether it's a recognition problem. So these factors, these attributes will actually enable you to decide on what kind of technique will best suit your given situation, what kind of architecture which will best suit to your problem scenario. So that's how the story goes on, and we always keep our fingers crossed in order to understand the capabilities of artificial intelligence, what all it can do. But sometimes it's required that you must fall back and also try to understand what are the limitations, because when we talk about AI, we don't like to talk about limitations, but we must also keep the limitations in mind before you try to do something, before you get tempted to apply AI techniques to any kind of problem situation. The limitations could be that it cannot think out of the box, because it's the human being who is going to write the program, who is going to build a model. So therefore, making a smarter machine with AI, it always remains a challenge. At the same time, it cannot think out of the box because it's going to behave exactly the manner it has been trained and the model it carries. Another limitation could be it has no feelings, no emotions. So an AI machine can be an understanding performer, an outstanding performer, but it cannot really have any feeling of what exactly it's doing. And of course, it also lacks the original creativity. AI cannot beat the power of the human intelligence in terms of creativity, and in terms of imaginations. And people have not really understood the creative nature of a human mind, how the human being really imagine. Probably we have got some grip over how human being thinks, how human beings they learn, and how they respond to external stimuli, how they handle problem situations. But at least we have not, till now, we have not understood the creative ability, the imaginative ability of a human being, because these things still remain as gray areas which people will be struggling for another century or so to understand what is the feeling, what the emotion, what is that creativity or the imagination, the special attributes that normally you find in the human being, right? So the story goes on, and I'm very much confident, because this area is such an area, because this area will never come to an end, for a very simple reason. In whatever that we try to do, we will only have a smaller understanding of the human problem-solving behavior, the human thought process. So as the research continues to understand the human thought process, as the research continues to understand the human problem-solving behavior by the neuroscientists, by the philosophers, and other people, the research in AI by the computer science community will continue to catch up with them in order to imbibe those attributes, those problem-solving characteristics in the form of programs, and try to come out with the AI machines or the AI systems, and claim that yes, we have come out with something, not realizing that those machines or those intelligence systems will soon fail when they are confronted with a situation for which the machine was not trained, or the machine has not learned to how to handle these kind of new situations. So this kind of a tussle will go on between the philosophers and the computer scientists, with the neuroscientists and the computer scientists, to always claim something, saying that yes, we have achieved, but soon soon it will be they will be proved that they are wrong, because they will fail to achieve certain things in a given scenario. So it's a very interesting application domain, and people will continue to work on this area, because at the moment we have achieved the symbol manipulation capabilities in a digital machine, but injecting that ability of semantics, the real understanding of text, is very difficult to achieve at this point of time. Unless we have that capability, we will not be able to appropriately program a computer's mind. If at all you are trying to program the computer's mind, probably you will not be able to do, because it's the mind which actually thinks, which actually does the reasoning. Of course, we are trying to do that using different reasoning models, but we are yet to reach that. And another thing is, it's clear that the common sense knowledge and the experience, capturing this common sense knowledge and experience of human beings, which gives that power to the human being to solve an interesting problem, is again another area which people will continue to work. So a nice comment, I always love this, by Rodney Brooks, who says, artificial intelligence is a tool, it's not a threat. Because many times people think, when the computers came, people said, okay, computers are going to take away our jobs. But now that people are talking about artificial intelligence coming into every area of our applications, now people think again, once artificial intelligence is implemented, that will be again threat to the human race. But again, I think it's not true, because this is going to be used just as a tool, but it's never a threat, because it's going to help us to solve our problems together, because the AI systems and the human being will live together, will coexist, and try to solve difficult problems in given situations for the betterment of the human kind. So with this, I just come to an end. I have also a class. So thanks for your patient hearing. In case you have some questions, probably you can ask, or we'll stop here. So once again, thank you so much for your patient hearing. At the same time, I'm very sorry. Twice or thrice I was a little disturbed. The Vice Chancellor came directly to my room because he was just giving a surprise visit. So that's how I was disturbed in between twice. But I'm extremely sorry about that.
Any questions from the participant? Sir, some of the participants need the PPT.
Yeah, okay. I just.
Manas sir.
Yeah, sure. I just pass those on to you. I'll send it.
Okay, sir.
After my class, I'll send it. I have a class, and after that, I'll send it. Okay.
Okay, sir. So
But-
it's
Any response? If not a question, some additions, some thought. Because whenever I listen to talks on AI, there are so many things that comes to my mind. I'm sure you must be also thinking in the same line. So if you want to add something to this, because this talk is just an initial talk, just as the session says, it's a foundation to AI. So I was very careful in keeping myself restricted to only that. I didn't talk about any algorithms. I didn't talk about any specific technique. So that's how it was designed.
okay. So any question from the participant end? So it's time to share the vote of thanks. So to the beautiful participant for the session 1. I would like to thanks to our session 1 speaker, Professor Dr. Manas Ranjan Patra. He is working in the Department of Computer Science, Barampur University, Barampur, Odisha, for his valuable talk on foundation of artificial intelligence and its challenges and application. And sir also covers a brief about like different intelligence algorithm, search space, state space, goal-driven algorithms, as well as future application of the artificial intelligence, machine learning, and deep learning. I would like to thank the AICT Intel communities and GIT University authorities, faculties, and participants. Thank you all. We will meet in the session 2. The session 2 is going to start from 3:30 onwards. Okay, so it's kind request to all the participants kindly join before 10 minutes. Thank you, Manas sir.
Thank you so much. Thank you so much.
Namaste, sir.
Thank you, sir. Namaste, sir.
Sir.
Namaste.
Sir, please on your camera. Sir.
No, sir already is on. Sir
It's
already
on. I'm on.
Yeah.
I'm
So
on.
Yeah.
it's a kind request to all the participants kindly on your camera.
All the participants are requested to turn on your video, please.
Sir, there's some trouble with my camera.
Okay, sir, no problem. Hey, we can understand. Thank you for your concern. Gopal, sir, no?
Yes.
Yeah, please.
Yes, I will take just a second.
Okay. Yeah.
Yes, sir.
Thank you, sir.
And all the participants, just informing you all that when you will get the PPT if the respected speakers will share with Raghavan sir. Definitely, you will get it from Raghavan sir. So no need to write it in the chat box because we don't want to keep anything with us because it will be knowledge is always shareable. As respected our today's speaker Manas sir already agreed to share it with Raghavan sir, and once he will get it, and definitely it will share it with you all. So kindly join the session at 3:30 before 10 minutes as Raghavan sir requested you all.
And for all the ones you have to join.
Okay. Thank you, brother. Thank you, Raghavan.
Thank you, sir.
Thank you, everybody. Thank you, the GIT faculty.
Thank you, sir. Thank you.
Thank you, sir.
Thank you.
Rohit, sir.
Yeah. Thank you.
And feedback we are going to collect through WhatsApp. WhatsApp group, we already created the WhatsApp groups.
Yes.
And that you you share your feedback for the session 1, and for overall feedback at the validity sessions, we are going to share the Google form. In that you share all the information. Okay, and for the attendance purpose, we are taking the automatic attendance at what time you are going to join and what time you are going to leave. All the information we have, so there is no need to share the separate Google Sheet for the attendance purpose.
Yes,
I think hope all the participants is agreed in that particular point.
Yes, sir.
Because I think we are sharing the same link. It's very difficult and for you also.
Sir, we
Someone
have been
saying something.
actually due to some network issue, have been joining more than once. So would there be an issue in
No,
that?
no, no,
Because we have
no.
been.
Go so for that, at least you have the two different entries there. Okay.
It,
Okay,
it,
sir.
um,
Thank you.
it
Thank you,
doesn't
sir.
mean that you